right, I'm going to cut you off. So 8.3, we are solving exponential equations. We were solving log equations. Exponentials are the opposite of logarithms, so a lot of similarities. So we're going to see exponents, and we're going to see a lot of bases, and the whole gist, the big skill that we need in order to solve an exponential equation is what you just did. So we wrote 49 as 7 to the power of 2. Our goal is to take numbers and rewrite them as numbers raised to an exponent. So 64, what you got? What power? 8 to the second power. 8 times 8 is 64. 8 squared, 64. We can rewrite it as a base with an exponent. 144, what you got? 12 to the second power. Very good. Okay, we rewrote it as a number to an exponent. That's the goal here. Okay, getting a little trickier. 27 is 3 to the third power. 3 times 3 times 3 is 27. Okay. 243. 243. 3 to the fifth. 3 times 3 times 3 times 3 times 3. 3 to the fifth. 243. Last one. 216. 6 to the third. Yes. Very good. Okay? This is the big skill that you need to know. This is the first step of solving any of our equations. Okay? Is making sure we can rewrite numbers as a smaller number to an exponent. Okay? Super important. Okay? Puzzle time. Here we go. Next. All right. Now I'm going to give you two numbers. Okay, look at example 1. We have 9 and 81. 9 and 81. The goal for each one of these in example 1 on the left is how can I rewrite 9 and 81 as the same number raised to an exponent. So for example, 9 can be rewritten as... Not how do we make 981. What can we rewrite 9 as? A number to what power?
3 to the second.
3 to the second power, okay? So 3 to the second. 81, we want to write as the same number to a different power. So 3 to what power gives you 81? 4? Check it. It is. 3 to the 4. Your goal is to get the same base, but different powers. Okay? So finish those 3 example 1s. Don't worry about example 2s yet. Example 1s. Make the base, rewrite the numbers as with the same base. They'll have different exponents, same base. How are we doing? More time? If it was 16, yes. Get lazy and start writing times 2. 2 times 2 times 6. They're good. Alright. Some of you are still working. That is okay. Second one. 8 and 128 can be rewritten as what? 2 bases with the exponent. What's our base for both? Both of them will have a base of 2. What's our exponents? 3 and 7. And again, we rewrote 2 different numbers as an exponent with the same base. Okay, what is important is our bases are the same. It is okay our exponents are different. They should be different. But our bases are the same. That's what we're trying to do. We're rewriting 2 numbers so that the base is exactly the same. 27 and 243, what you got for me? 3 to the 3rd and 3 to the 5th. Good. Again, the big idea here, same base. Last but not least, tricky, what do we got? 4 to the 3rd and 4 to the 4th, or 2 to the... There's 2 ways to do it. 4 to the 3rd. Oh, I don't... 2 to the, what's the first one? 2 to the... 2 to the 6, and 2 to the 8. Ah, yes. There are 2 ways to do this one. You can do it with bases of 4. Or which one? This? You got what as well? So we can rewrite as 64 as 8 to the power of 2, but can you do 8 to the power of something to get 256? No. So you're right, you can rewrite one of them as 8 to a power, but we're trying to get them both to be the same. Does that make sense? Yeah. Other side, same thing but different. These are what we are going to start learning how to solve. So this is the pattern you are looking for. If you look at this first one, you see that, first off, if we were trying to solve for x, where is the x? It's in the exponent, and that's a big problem in math. Algebra 1 is kind of out the door when our variable, what we're trying to find, is an exponent. Okay? We can't use our regular little waterfall and move things from side to side to solve for an exponent. It's a little trickier. So we're going to use what we just did, and we're just going to do the first step of the process. So on each side, what is the base? What is the base on the left side? 2. On the right side, what is the base? There's only one thing. 4. So you are going to look at your base on each side, and the goal is to get them to be the same. On the left side, we have 2 to the power of 2x, and on the right side, we have a 4. What do we want to rewrite that 4 as? 2 to the 2nd power. If we rewrite this as 2 to the 2x equals 2 to the second. Are the bases now the same? Are the bases the same on both sides? Yes. But both of them have a base of, remember, we don't care what the exponents are, we just want to know what the bases are. And these bases are the same, and you'll see in a second that now we have a trick to solve that. Okay, so for the next three, your goal is to rewrite the equation so that the bases are the same on both sides. Rewrite both sides so that the bases are the same. These can't be solved until our bases are the same. Same base. Feels like I just walked thread crooked all day now.
Why did I finish the sweets?
You're asking the wrong question. Why didn't I? You know, why keep it the same? You know?
What is the second one say?
The second one says 3 to the power of 7x minus 2 equals 81.
Oh, so the first one's already complete?
Yeah, that's it. That's all you're doing in this right now. Will we do more in a second? We always do more. This is a class about more, more, more. This is the greediest class in the building. More. More. You can always do more.
Phrasing. That's simple.
Yeah, so just remember, well, I should get more thanks yous. Tokar, thanks for not doing more because I can always make it more.
Phrasing.
More sentences. More steps. More notes. More practice. To the 2x minus 2. 4 to the power of 2x minus 2 equals 64 x minus 2.
You right to right?
What?
You right?
Let's find out. Alright, here we go. What's the base on the left? What's the base on the right? Okay. Which one does it make sense we gotta make smaller? Right? We wouldn't be changing this one, would we? You can't. That stays the same. So something you should be looking for is which one do I change, which one do I not change, do I need to change both? Left side I don't need to change. 3 can't be rewritten, but 81 can be rewritten as 3 to the 4th power. And look at that. Left base, right base, same. Okay? This is now solvable. Next one. Again, we have 3 on the left, 243 on the right. 3 we can't rewrite, so we're going to leave it. 3 to the 4x. However, the right side, 243, can be rewritten.
So basically the number that's on the
Yep.
basically the number that's on the right side is what we did on the exact one.
Yes, you're doing the exact same thing, but different. Exactly the same. You're making both the left and the right side the same. But yeah, 243 is 3 to the what? But weird, I have an x there. What's it going to become? 3 to the 5th times x. And what is 5 times x? Yeah. We multiply exponents. When we add a power to a power, we multiply them. So look, 3 on the left, 3 on the right, base on the left and right are the same. That is now solvable. It is, but. Okay, last one, trickiest one. 4 on the left, 64 on the right. Can we get away with changing only one of these? Look, this is how you know. Here, we looked at 3 and we're like, oh, 3 to a power gives us 243. Does 4 to any power give you 64?
Yes.
4 to what power? Okay. So that means we can leave the left side. So I can keep this as 4 to the 2x minus 2 equals, what am I going to do on the right? 64 can be rewritten as 4 to the what? 4 to the 3rd. But look, I have all that x minus 2. And what do I do when I have a power to a power? What do I do with them? Multiply. But when I multiply one thing by two things, what do I get to do? What do I do here? We're not going to do it yet, but yeah, I would end up distributing. We're going to do that in a bit. We don't have to do it, but that's what would happen there. Now, is that the only way to do that one? You want to do the way that's doing too much?
No.
Come on. What other base could you rewrite both of them as? You could do 2. Right? I could rewrite this as 2 to the 2nd and multiply. And I could rewrite 64 as 2 to the 6th and multiply. So there's more than one way I could even do that one. Now 4 is the better choice, less work. Okay? But that's the idea here. That's what we're trying to do. Okay, so I have a little more for you. Now it's time to do the full shebang. Okay? The full shebang. Start to finish.